So what you have on your table is a success criteria tool that we are going to be using today. And I'm going to model how to use it. Okay, you are going to be doing a word problem where you are going to apply everything we have learned so far. Okay, so in the last unit, we have been learning about fractions. So our unit three, it's about adding and subtracting fractions. Okay, but before going over there, we are going to be successful when we can identify and we can represent all this list of things that you can do. So the purpose of this assessment is that you are going to do a word problem and you are going to auto-evaluate, you're going to self-evaluate. You're going to tell me how do you feel on all the list of things that we need to do in order to add and subtract fractions. For example, the first one, I know I'm successful when I can identify elements of a fraction. So you all know elements of fractions since you were in third grade. So what are those elements of fractions?
Numerator and denominator?
Numerator and denominator. So what I want you to do when you do your word problem at the end is to identify or label your numerator and your denominator. Then the next part of your task is to represent the fraction that you're gonna get as a result of your computations and your analysis of your word problem into an area model. Okay, so we are going to review again what area models are and what do we use them. But if you don't feel like you don't master your area models or you don't know how to use your models, you are going to put a checklist here where it says I still need help. This is for me to understand that you need more help in certain parts of doing your computations and doing your adding and subtracting fractions. But if you do your problem and you understand it very well, so you're gonna give me a thumbs up or a check mark where it says I know this. The whole purpose of this is to go all over the whole process of adding and subtracting fractions. So first, I want you to apply everything you know how to attack a word problem. And then you are going to, once you get your answer, you are going to identify those elements of fractions. Then you're going to draw your area models. Then you are going to plot that fraction in a number line. Then you are going to get a fraction equivalent using your area models. Then you are going to generate your equivalent fractions in an abstract way. How do we do it in an abstract way? What does it mean abstract? What does it mean abstract? When we're doing a word problem and we do computations, is that when we use models or when we write the numbers and we do the computations? Angie?
It's when we write the numbers and we do the computation.
Okay, yes. So you are going to be doing your abstract model. You're going to be using your abstract model. And this checklist has everything you need to remember about each of the concepts. If you go here, it will explain to you how to simplify fractions. And at the end, you are going to give me a justify or a reason why you believe that's the answer of the problem. So let's practice one, okay? So L above 2/6 of a pound of peppermints and 2/6 of a pound of gummy bears. How much candy did Ella buy? Okay, the first question I'm going to ask you to do is to represent your answer in a fraction in a number line. Represent your answer in an area model. Okay, so let's underline important things I'm asking you to do. So you're going to represent your fraction in a number line. Then, once you do this, you are going to get an equivalent fraction from your area model. So I'm asking you to do an equivalent fraction. Then you're going to simplify your answer to the simplest form. And the most important thing, I want you to justify your answer, okay? So the first step we do when we attack a word problem is that we underline the question. So what is the question, guys?
How much candy did Ella buy?
How much candy did Ella buy? What are the things we need from the problem so we can circle them?
Details.
Huh?
We circle
We circle, yeah. How much did she buy from? 2.6
peppermint.
of pounds of peppermint, okay? And how much did she buy from gummy bears? 2.6. Okay, so she bought 2.6 of gummy bears. Okay? So, what do we have to do in order for us to answer the question?
Make a model.
We can make a model, but what operation are we using in that?
Line.
That's something we can use for that, but what operation are we doing there? How did you get the answer to that question?
Finding a total by adding.
By adding. Awesome. By adding. Okay? So, you can use a model first, but let's do first the addition. So, how many peppermints you bought?
2.6.
Okay, so we can write peppermints. Okay, so equal to 2.6. Okay, and how many gummy bears?
2.6.
2.6 of a pound. That's gonna call things by its name. Okay, so 2.6. Okay, so if we add them, we are adding a fraction with what kind of denominators we have there?
Equal.
Equal or like denominators. So what do we do when we have like denominators? What is the denominator here? It's the same one. So my denominator is gonna be 6. And we add numerators, ¿verdad? Okay, so 2 plus 2. And we get a fraction of 4.6. Okay, so now that we have the answer, we know that she bought 4.6 of a pound of candy. What is my first question? What do we have to do with this line? What do we have to do with this fraction? I'm sorry. What do we do with the answer? What is my first question? Represent your answer, the fraction in a number line. So, is this a proper or an improper fraction? A proper fraction. Okay, so the first step we're gonna do is to represent this fraction in a number line. So, where does my number line goes from? 0 to 1. Okay, because we are going to split this line into how many parts? 6. Okay, so because it's an even number, I can say that halfway is going to be 3/6. So 4, 6, 5, 6, and what is the whole? 6, 6. Okay, and if I start here is 0.6, which is equal to 0.6 is equal to nothing, 0. Okay, good. So 1.6, 2.6. How can I represent my answer on the number line? Where do I go? Angie.
You put a dot in the 4.6.
Good job. A dot on the 4.6 and I can make a square to 4.6. So did I do my question 1? Yes. So we can check in our checklist, we can check that we identify elements of a fraction that we can represent area through the models. We haven't done that. But here on plot the fractions on a number line, I will make a check because I know this. But if you are having troubles with that part, you are going to make a check on I need more help. Okay, Question number 2. What is number 2?
Represent your answer in an area model.
Oh, okay, so if I want to represent this in an area model, I'm going to choose a square or a rectangle or whatever I can find. So how many lines I'm going to split this rectangle or square?
6.
6. Excellent. So 1, 2, 3, 4, 5, and 6. So how many shaded parts are going to be in that square?
4.
4. Excellent. So 1, 2, 3, and 4. So is this the same as this?
Yes.
Yes. So question number 2, it's done. So get an equivalent fraction from your area model. How do we get an equivalent fraction from my area model? How can I do it?
Putting a horizontal.
Putting a vertical line? Splitting by half? Yeah. Okay, so if I want to get an equivalent fraction, I will split my model into 2 parts. So now, number 3, my equivalent fraction is what? 1, 2, 3, 4, 5, 6, 7, 8 over 12. So my equivalent, good job, Adam. So my equivalent fraction is 8 12s. Okay? And if I want to do it from the abstract model, what do? I copy my fraction and what?
Multiply 2.
And you multiply times 2. Okay? Or any number, but in this case, based on this model, we multiply times 2. So this is 8 12s. Okay? So it's the same way, like I told you. Every path takes you to Rome. So todos los caminos te llevan a Roma. Okay? So the next question, it says simplify your answer to the simplest form. Okay? So what do we do to simplify 4, 6? What are the steps? So if you don't remember, I'm going to remember you. So we get the factors. So what are the factors of 4?
1. 2
And 4. Okay. Factors of 6. It's just factors of 4, factors of 6.
1, 2, 3,
And 6. Okay, so which one is my greatest common factor?
6? No.
2. 2 is my greatest common factor. 2 is my greatest common factor. So I'm going to divide my fraction top and the numerator and denominator divided by 2. Okay? So how much do I get? 2 thirds. Is this my simplest form? Can I simplify even more? No. Okay, so this is my simplest form. Okay? So, and when I'm going to give my answer, my justification says, based on my area models, I know that she bought in total 4 6 of candy because I add my fractions and I got this result based on my work. That's what I want you to answer when I say justify your answer.